Okay, guys, we are looking at organic naming right now, aka organic nomenclature. On the summer assignment, there were also some video links there if you want like a more in-depth tutorial of this, because this is gonna be a quick one. And it's Leah Forsai, and she's great. So if organic really confuses you, please take a look at that. The good news is there's only gonna be like 5 questions like this on your test when you come back, but it's obviously on your packet as well where you have to learn it. So please take a look at it. Okay, so first thing with organic is you need to determine how many carbons there are, because organic chemistry is the chemistry of carbons, pretty much. And so when you look at a structure, and here's a couple different examples of structures here, you're going to count the carbons. And so when we look at the carbons, that's going to be our prefix. So our prefixes are, for 1, it's meth, for 2, it's eth, for 3, it's prot, and again, you're going to have to memorize these. For 4, it's bute. For 5, it's pent, and then these guys are pretty much the same as you're used to. 6 is hex, 7 is hept, 7 is hept, I need to say hepta and hexa, and 8 is octa, 9 is nona, and 10 is deca, and we're not gonna have you do any more than that. Those are like that. So that's the prefix, and again, that's based on the number of carbons. So if I'm looking at this guy down here, I have 1, 2, 3, 4. So the prefix is going to be bute, because 4 is bute here. And then we gotta look at the suffix of the name. So that depends on if there's any double or triple bonds. So you can see this thing is all singles. So my suffix here is going to be ane. So this thing right here is just going to be called butane. Now, chemists in general are pretty lazy. We don't like to write all this out, even though it doesn't seem like a lot. I'd rather draw that, because that's also butane. So I want to show you, this indicates each tip, this is 1, 2, 3, 4 carbons. So that also is butane because there's no double or triple bonds. So that's either way you could write it. These lines here, if it's with the carbons, is implying these are hydrogens. If you have a line off of this, because you see how there's no lines off of this, if you have a line off of that though, that's implying it's a methyl group, which I'm going to show you in a second. So here, this CH3 is a methyl group. All right, and a lot of times our other substituents we're going to add on, we're going to have like halides. So that's anything from the halogen group. So chlorine, fluorine, bromine, those are just some examples. And I'm going to show you what to do here. So let me talk about if it has a double or triple bond, what you do. So let me just show you, let's say that this butane here, let's make it a little different. So let's just put this here, okay? So now we know we're going to number our carbons, and you always want to number to give us the lowest value for where this double is. So 1, 2, 3, 4, 1, 2, 3, 4. So it's the same each direction, so it doesn't matter. So we're going to number it 1, 2, 3, 4, okay? And we're going to give the number of the location of the double bond. So this is going to be a 2, and then there's 4 carbons, so it's bute, and then my suffix is ene, because it's a double bond. Okay, that's where all that came from. So let's take a look up here where we don't have any double or triples. So this is, the ending here is going to be ane. That's easy. And we want to start numbering where the substituents give us the lower number. So if I number this way, it'd be 1, 2, 3, 4, 5, 6. But if I number this way, this would be at the 2. So I have to number from the opposite direction this time. Because again, you want the lowest number of substituent. So you're going to give the location of the substituent. So this is a 2. And you give dashes between the numbers, 2, and we're going to say bromo. And how many? We said 6, so the prefix here is going to be hexane, and that should be move this over a little bit. So we don't need a space there, but that's just because I didn't room. Okay, so 2 bromohexane is what that thing would look like. If I had another bromo on there, let's just add this in to do something different. So let's say I had another bromo here, and we know this is still 3. So now we have to indicate the location of both of these guys. So this is going to be a 2, 3, because that's the location of each of them, 2, 3. And now we don't just have one bromo, this is now going to be dibromohexane. Okay, so that's how these things can change up. This guy here, you can see, has a double bond. So let's count our carbons. And again, we want to go from the lowest direction. So we're going to start from this way. So 1, 2, 3, 4. And so that means this is a bute. And our suffix, because we have a double bond, is ene. And we want to locate we want to give the location of the double bond, so it's at the 2 location. And P.S. you might see it like this, bute 2 ene, but I don't really like that look. These are both correct. I don't like that look because it looks like a middle name. I just don't like it. But you're welcome to do it like that. Okay, so 2-butene, and then let's do the substituent here. So that's going to be because the double bond's also at the 2, so that's going to be a 2-methyl 2-butene. That's what that thing's called. Okay, now something completely different. We have something that's all connected, which is not super common. The prefix when it's all connected like that is cyclo. So you use cyclo when it's connected like that. And then we look at our carbons here. We have 1, 2, 3. Our prefix then is prop, so cycloprop. And we don't have any double or triple bonds, so this is a cyclopropane. That's what it looks like. If you have substituents on something like that, like you have this here, this would always be the 1 position, because you always want to start with the lowest. So it'd be 1, 2, 3. And this would be a 1. You actually wouldn't even put 1. You would just say it's methyl cyclopropane. That's what that would look like. Okay. All right. As you get on here, now we're looking at the name and trying to get the structure. So first thing I'm going to look at is how many carbons are there. So there's 5, and I'll do one like this out, and I'll do one like the skeletal. So 1, 2, 3, 4, 5. You guys are new, it might be easier to write out the carbons like that. So 1, 2, 3, 4, 5. That's our pent. It's ane, so they're all single bonds, so we're good. It's telling us there's a chloro at 4. So 1, 2, 3, 4. There's a chloro here, and then there's a methyl on the 3. So 1, 2, 3. We'll put a methyl here. And then it's implied, but you could put that these guys are hydrogens here. That's what that kind of indicates. If you don't put that, it's not the end of the world. If I wanted to draw that skeletal wise, I would go like this. I'd say 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, like that. And then I'd have a 4 chloro and a 3 methyl, like that. So that's quicker to draw, yes. It just depends on your preference. We're fine with either. Okay, for this guy, we have a heptene. So we have 7 carbons. So I'm going to try to, let's see, 1, 2, 3. I always have to count it after. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, and it says that the double bond, this is indicating a double bond, is on carbon number 6. So that means we have double bond here, because that would be 6 and 7. I'll number it 1, 2, 3, 4, 5, 6, 7. So that's on 6. And then we have 2 methyls on 2. So I'm going to just erase this so we have room. And I'm going to put a CH3 here and a CH3 here. And that's what that thing would look like. Okay? Hopefully you get a little overview of some organic stuff. If you need help with it, again, look